Okay, in this video we're going to go over how to rearrange an equation algebraically, and you will have to do this several times in physics. There are many variables in an equation sometimes, and you'll need to know how to isolate a variable in order to solve for it. So let's start out with sample A here, practice problem A. We have solve for d. D over t equals v, and we'll worry about what these variables are later when we start talking about distance, time, velocity, things like that, but we'll just for right now, it doesn't matter what they are. Let's just rearrange these different variables. Solve for d. You have d over t equals v, and we need to isolate d, get d by itself. So how would I get d by itself? I need to get rid of t, right? T is on this side with v, so let's get rid of t. How can you get rid of t? If you're dividing by t, you just have to think when you're doing these operations, what is the opposite of what it's doing right now? That's how I get rid of it. So if we're dividing by it right now, the opposite of that is to multiply both sides by t to get rid of it. So we'll multiply both sides by t. T will cancel out there. So we're left with d equals v times t. And that's how you solve for d. That's how you get d by itself. Just multiply both sides by d. Okay, and through the magic of the pause button, we're already set up for our next example, b. Solve for t this time. So this time we have v equals d over t, and we want to solve for t. In order to do that, I need to get t by itself on this side of the equation. So I know sometimes tuition tells you, okay, where d is on top over here, so I need to divide by d to get rid of it. Never ever divide by the numerator. If you do, and we divide by d down here, you'll end up with 1 over t. That is not t by itself, that is 1 over t, and that does not solve for t. Please never divide by the numerator. So if you want to isolate a variable, and it's on the bottom, you have to multiply both sides by that, just like we did over here. So we know that t will go over here and be with v, but we'll have to separate that later. But to get it out of this equation, out of this fraction, we need to multiply both sides by t first. So let's do that. We'll multiply both sides by t, and you wind up with t times v equals d. So now we have it out of a fraction, but we want to solve for t, and d is isolated right now, so we need to isolate t and get it by itself. So if we're multiplying by v, what's the opposite of that? What can we do? Hopefully you said divide by. So we'll divide both sides by v. That will cancel out v, and t will equal d over v. And that's how we isolate t in that equation. Okay, now we're at sample problem C, and we have solve for velocity final. That's what that is, VF. V sub f, this is velocity, and that's the final velocity. So, and among other things, we'll get to many things later, and you'll understand what that is. But right now, just know how to rearrange this algebraically. Look at this equation over here. D equals 1/2 velocity final plus velocity initial times time. That's pretty complex, so we're going to have to do quite a few things to isolate this variable by itself. We need to get VF by itself, so we got to get rid of all this other stuff. So it doesn't matter where you begin, just as long as you do everything you need to do to isolate VF. So if we want to first, let's go ahead, we have 1/2 times this. What is the opposite of 1/2? It's 2 over 1, right? So let's multiply both sides by 2. And we'll end up with 2d equals, half will cancel along with the 2, and that will equal velocity final plus velocity initial times time. So right now, here we are. We're breaking it down slowly. Time would be our next thing. It's on the outside of the parentheses also, so let's get rid of it so we can just be left with these two. And what's the opposite of multiplying by? It is dividing. So we'll divide both sides by t. It will cancel out over here, so we'll be left with 2d over t equals velocity final plus velocity initial. And that's what the I stands for, initial. So 2d over t equals that. Now we want to get velocity final by itself. So in order to do that, we got to get rid of vi. Well, if we're adding velocity initial, what do we do over here? We subtract it, right? So if we subtract velocity initial from both sides, we will have 2d over t minus velocity initial equals velocity final, and that will cancel. So there we are. And that's how you isolate velocity final out of this. Okay, and in our last example we have solve for v, and we have this equation over here, which is force centripetal F sub c equals mv squared over r. And it doesn't matter what all these variables stand for. Let's just know how to isolate the v by itself. So we have Fc equals mv squared over r. First step, let's go ahead and get rid of that r underneath. We want to get v by itself, so we need to get rid of the m and the r and also the square. So first step would just be to get rid of the r. So we'll multiply both sides times r, and you'll end up with Fc r, or you could just write FCR or FC times r. Does not matter as long as you understand what the function of that is. And that would leave mv squared by itself. Alright, now we need to still get rid of everything except v, so let's get rid of that m. We'll divide both sides by m to get rid of it. So we'll end up with FCR over m equals v squared. Now that's still not what we wanted, because this is v squared and it wants to solve for just v, not v times v. So in order to get rid of the square, we'll take the square root of both sides. So you will end up with the square root of Fc times r over m, and that will be equal to v. And that is how you isolate and solve for v out of that equation. Okay, now the last thing we're going to do here is solve with actual numbers for the variables. Like we were rearranging just variables earlier. Now we're going to plug some numbers into those variables. And look, it is totally up to you how you want to solve these problems. If you want to rearrange the variables first and then solve for t, or if you want to plug in the numbers. Usually I like plugging in numbers. I deal better with numbers than variables, but you do need to know how to rearrange these variables to be able to solve for the missing ones. So as this is, we're solving for this equation, d equals VIT plus 1/2 AT squared. If your d equals 1.2, a equals 1.62, and VI equals 0, what is t? Now I'm not using all the names for these variables right now. This is distance, this is velocity initial, this is time, this is acceleration, but we'll get to that later. I don't want to confuse you with anything right now. Just concentrate on how to rearrange variables. Okay, so for d, we're going to have 1.2, so I'm rewriting this with the numbers in it. So d equals 1.2, and 1.2 equals VIT. VI is 0 times t plus 1/2 a. A is 1.62. VI is 0. I'm sorry, t squared. Sorry about that. Okay, let me make sure I rewrote that correctly. 1/2 a t squared. VIT and d. Okay, I think we're good to go. Alright, now, we just need to rearrange these to solve for t. Well, guess what? Anything times 0 is 0, so this t is going to cancel out immediately. We're going to have just t squared left. So 1.2 equals 1/2 times 1.62 t squared. Okay, and you can put the parentheses around it if you'd like or not. It does not matter. Okay, as long as it's next to that parentheses, you know you're multiplying it by that. So 1.2 times 1.2 equals 1/2 times 1.62 times t squared. We are going to get rid of everything except t squared, just like we did earlier. So to get rid of a half, you multiply it by 2. So we're going to multiply by 2 on both sides of the equation. And if my math does not fail me, that is 2.4. 2.4 equals 1.62 times t squared. Okay. Now we need to get t squared by itself so we can get rid of 1.62. So we'll divide. It's multiplied by it. We're going to divide by 1.62. And that leaves us with t squared. I'm going to do my math real quick. So 2.4 divided by 1.62. That equals 1.48. Not too worried about sig figs right now. Just want to show you how to work this, but we'll do it anyway. 2 sig figs here, 3 sig figs there. That means 2 sig figs for our answer. So 1.48 will be 1.5. You'll find out in my class that outside of labs where you're actually using instruments you're measuring with, I'm not too difficult on sig figs. I want you to understand sig figs and what they mean and how to calculate in the correct number of sig figs for our labs. But in your work, if you work an entire problem correctly and you end up with just an incorrect number of sig figs in your final answer, there is no way I would punish you for that. I just don't see the point in that. Okay, if you work all the physics correctly, I'm not going to punish you on the mathematics. Okay, and 1.5 equals t squared, and let's get rid of this square. We need t. We are solving for t, not t squared. So the way we do that is take the square root. Square root of 1.5 equals t, and what is that? Square root 1.5 is 1.224, so let's go with 1.2. So 1.2 equals t, and what I will like to see in your work when we're doing this is, I'm not a real stickler for sig figs in your regular worksheet problems and on tests, only in the lab, but I am a stickler for units. You do need your units, but since there were no units given in this problem, you're not accountable for any units here. But if there were units, we would definitely include that. But our final answer for this final problem on this video is 1.2 equals the time after we substituted in the numbers for our variables, isolated, and solved for t.